Thanks for joining us today. My name is Jay. We're going to do this Learn Live session, and it is called Scale Your Cloud Resources with Elasticity. Welcome to this session. I am Jay Gordon. I am a cloud advocate. I focus on DevOps and helping people get the most out of the fundamentals that make up Microsoft Azure. I live in Brooklyn, New York. It's a pretty nice place, a little snowy today, though. I've been part of scaling cloud applications at places like BuzzFeed in the past, and today I hope to share some of the experience that I've had in the past and the knowledge that I have. And to help me with that, I have my co-host and Microsoft Student Ambassador. Why don't you introduce yourself?
Hello, everyone. I'm Dwitrisha Saha, and we are so excited to be able to share this session with you. And we hope you enjoyed as much as we enjoyed creating this session. And so my name is Dwitrisha, and I am a student at Manipal Institute of Technology, and I'm planning to graduate in 2023 with my major in information technology.
We always need more people in IT, and I'm glad to hear that you are one of them. So this entire session that you're going to watch today is based off the Microsoft Learn module of the very same name. Scale Your Cloud Resources with Elasticity. You can get all this content there right now for free.
Yeah, so the best part of it is this is a free training, and whether you are a new user or a cloud veteran, this is an amazing place to expand your knowledge about Azure.
Absolutely. So you can go to aka.ms/CMU Scale Cloud right now. Or after the session, whenever it makes sense, and you can go ahead and pay attention. And speaking of paying attention to these things, we're going to have polls for you to go ahead and answer today. We're also going to have Q&A. We're going to love having you part of this session. And if you want to watch this again, or you missed a replay, you missed the previous version. The previous edition of this series, Learn Live, is going to be available right here. You can watch it whenever you want, aka.ms/Learn Live. You can watch all the session recordings from this Learn Live series right there. So we're going to get started, and in order to get started, you're going to have to know little prerequisites like what cloud computing is, and you're going to have to understand how cloud services work, specifically specific cloud models like infrastructure as a service, platform as a service, software as a service. If you already have these, it'll really help you understand these learning objectives, like describing load patterns, enumerate strategies from considerations from scaling cloud apps, discussing the advantages of auto-scaling and the mechanisms used to achieve it. Describe the importance of load balancing cloud applications and enumerate the various methods to achieve it, and list the primary benefits of serverless computing and explain the concept of serverless functions. And so here's our agenda. Dwitrisha and I are going to help you get through this. We'll talk about our introduction of what it is, what it was, and what it will be. We'll talk about compute load patterns, scaling compute resources, automated scaling on the cloud, one of my personal favorites, load balancing, serverless computers, and then we'll summarize everything. Dwitrisha, are you ready for this amazing session we're doing for everybody?
I'm so excited, and I hope our audience is as excited as I am.
Absolutely. And so we're going to continue along. And why don't you tell everybody about this live and interactivity, Dwitrisha?
Yes. So our expert moderators are standing by to answer your questions. And Jay and I will even answer some of them live right now. So just pop your questions into the chat on Learn TV. And if you're watching on YouTube, Twitch, or Twitter, just head over to Learn TV and join the chat.
That's right, aka.ms/Learn Live TV. Love it, love it. And for those of you in the chat, we'd love to get to know you a little bit. We're going to add a few of those polls, so go ahead and start answering them as you go. And so, Dwitrisha, we've got our first poll. Which role best describes you?
So my role currently is now a student. Mm-hmm. And someday I would like to change my role to D, professional IT pro.
Awesome. That's I guess where I would put myself now. I'm in D. I've had about 20 years of experience doing a lot of this stuff, and that's why I feel really, really comfortable talking to you all about it. And so I have one more question, and Patricia, I know you've used Microsoft Learn,
Mhm.
but I want to
Yes,
know if the other. Go ahead.
yeah, I used Microsoft Learn when I was preparing for my Microsoft certifications AZ 900, and it was so amazing to learn. And also the gamification about of learning and then earning the points and getting levels makes it so much better and a great learning experience.
Absolutely. Free 2,000 modules. And they cover a wide range of topics from SQL to understanding scaling, like we're talking about right now. All these different things you can learn right there. All right. Are we all ready to get started? What do you think, Patricia? You ready?
Absolutely.
Okay. And just a reminder, ask questions to the moderator. We'll try to get to them as quickly as we can. And so moving to the cloud has a ton of advantages, but one of the more important is elasticity. This means that resources that can make up your apps or other IT processes can be dynamically brought online to meet increased demand and taken offline when they're just no longer needed, so you can reduce your costs. So like think of it as a balloon that expands in size when more capacity is needed, but contracts to its original size when that demand diminishes. So if you're charged for the volume of the air stored in the balloon, you want it to be large enough, but never larger than it needs to be.
Yes, and so a classic example of the need of elasticity occurs when an organization's website experiences unusually high loads. So if the site can't scale to meet demand, requests take longer to process because they're queued for the processor time. And so if I am the end user, I am going to be frustrated with the load times and may even think that the site is down.
Patricia, one of the hard parts about that is it could really damage your website or your business's reputation. If it's down, people are going to think they've got a problem. Why should I trust them?
Yeah, it would be very frustrating indeed.
Absolutely. And so some loads are predictable. And for example, Domino's Pizza sees a peak demand for its website on holidays, such as Thanksgiving and New Year's Eve, and even like during major events, such as, say, the big baseball series or the huge football game. Other loads are not quite as predictable. They may occur because of maybe a tweet goes viral or your favorite team won the World Cup, or just due to factors that an organization just can't anticipate. And so next we're going to talk a little bit about compute load patterns. You ready, Dwitrisha? Remind everybody, if you will. Would you remind them for me, Dwitrisha, that they can ask questions in the chat?
Yes, feel free to ask questions in the chat about any doubt or any questions you might be having related to what we are talking about, and we'll be very happy to answer them. And our moderators are waiting as well.
Awesome.
So if the traffic to a cloud resource, such as a virtual machine or a web app, were constant and unchanging, there would be no need to scale. But our traffic to the apps is constantly changing. And before we discuss how to scale, let's discuss why we scale.
So first, let's talk about consistent growth, which is among the easiest load patterns to compensate for because change is steady and gradual. So one of the most common drivers for the need to scale is consistent growth in demand. This chart right here shows the traffic to a company's website over the period of about 24 months. The company is growing rapidly, and the traffic to its website reflects that. If we assume that one server can handle 5,000 requests per unit of time, the company starts with perhaps 3 or 4 web servers, but needs roughly 22 years in order to keep with the increasing demand and continue serving its customers well. Dwitrisha, I do not have 22 years to order a pizza.
That sounds really frustrating. So everybody wants a good pizza and in very less time. So the rapid elasticity offered by cloud computing is essential when the load fluctuates in an unpredictable manner over relatively short periods of time. This chart shows the load on a website over a 24-hour period. Once more, assuming that one server can handle 5,000 requests per unit of time. The number of servers needed varies from 2 to 16 over the course of the day. We could accommodate this traffic by keeping 16 virtual web servers online at all times. But recall the cloud service providers charge for virtual machines even when they're idle. The excess capacity would not only waste energy, but roughly double the cost.
Absolutely. Very, very true. And so let's next look at cyclical loads. And our chart here shows a load that increases and decreases in a regular and somewhat predictable pattern. So for example, demand goes up during work hours and falls back during evening and nighttime hours. At its peak, this load requires about 20 servers to handle demand. Once more, assuming that 5,000 servers in and out of 24 hours a day. Requests per time server. And it's unreasonable to rotate physical servers in and out all hours of the day. But virtual servers can easily be provisioned and deprovisioned on a schedule to make sure that the server capacity roughly equals demand. Physical servers sitting idle or lightly utilized 12 hours a day represent unwanted capex or capital expenditure and unnecessary energy consumption because we all want to go green, right? So virtual servers come at a cost as well, but they can be deprovisioned when they're not needed and give you a quick option to recreate them when you do need them. So Dwitrisha, that ability to create, destroy when you need it, super important.
Mm-hmm. So one of the most difficult patterns to deal with from a cost and maintenance standpoint is one that incurs unpredictable bursts like in this chart. So if the peaks are predictable, for example, if the website serves a pizza delivery service that experiences higher loads on weekends and holidays, and then extra capacity can be planned for. But if they are not predictable, we must be prepared to deal with them at any time.
Absolutely. Unpredictability. It's a huge part of the internet. It's very, very hard to make big decisions about how traffic's going to happen when you're not always sure. And so, Dwitrisha, it's time for a knowledge check. And all of our viewers, they can go ahead and answer the questions on the chat in the poll section on aka.ms/learnlivetv. But I have a question first before we get to our knowledge check. We got a question from a guest, Dwitrisha, and they want to know when is the right time to use a load balancer. So I can personally say the right time to use a load balancer is almost at the beginning. The very beginning of your application build. Sometimes you should go ahead and build that infrastructure so you're ready for growth rather than having to shoehorn in a load balancer into your solution later on. Mm-hmm. Cool. So let's get to our first question that our poll is going to ask. And so this one is for our attendees, viewers, whatever you want to call them, Dwitrisha, but I want to ask you the question and see if you've got it right, okay? Mm-hmm. So assume one server can handle 5,000 requests per unit of time and that a website experiences loads that vary relatively even from a low of 5,000 to a peak of 25,000. The site is hosted in a cloud using virtual machines and each VM costs about $4 a day. What is the approximate annual difference in cost between providing elastic capacity that is sized to meet demand and constant capacity sized to handle peak loads? Okay,
so let's take a second here and let's see what our audience has to say on the poll.
Absolutely. And if you're watching live now, make sure you go into the chat on the right side. You will see a little poll. Go ahead, answer one of these questions. But Dwitrisha, I think you'll be able to answer the question for me. What do you think the answer is?
So we have two servers and they cost $4 per day, and we have 365 days a year. So if we multiply all of them, we get the answer as $2,920.
That makes a ton of sense to me. I mean, it's simple math, right?
Mm-hmm. I hope everybody was able to answer that, and stay
Absolutely.
tuned for more knowledge checks.
And absolutely. And remember, you can purchase reservations as well, which allow you to pay for a certain amount of usage per month at a discounted rate. So something like Azure reservations, they help you to save money by committing to, say, like 1 year or 3 year plans for multiple products. So just keep that in mind.
Mm-hmm.
So next, let's talk a little bit about compute resources and how we scale them. So it's important to note that although the cloud enables administrators to provision newer or better resources, cost is always an opposing factor that needs to be considered. Therefore, even though it is beneficial to scale up or scale out, it's important to recognize when to scale in or down so we can save some money. It's always a good idea, right, Dwitrisha? You got to save a little bit of cheddar.
Yeah. So now we'll talk about horizontal scaling. And horizontal scaling is a strategy whereby additional resources are added to the system or extraneous resources are removed from the system over time. This type of scaling is beneficial for the service tier when the load on the system fluctuates inconsistently or in an unpredictable manner. The nature of the fluctuating load makes it essential to provision the correct amount of resources to handle the load at all times.
So I love this little chart or infographic that we have here showing, the load balancer helping us to scale out and scale in based on our utilization. Makes a ton of sense to me.
Yeah, and also it makes it very easy to understand.
Absolutely. And so horizontal scaling is just one way to achieve elasticity, but it's not the only way. So suppose the traffic, your website rarely exceeds about 15,000 requests per unit of the time, and you provision a single large instance that can handle about 20,000. Enough to serve a normal traffic, but pretty well and account for the minor peaks. If the load on the website grows, you could reasonably accommodate the increase in traffic by replacing the server instance with one that has twice as many CPU cores or twice as much RAM. That's known as scaling up. The primary challenge in vertical scaling is that there is generally some switchover time that can be considered downtime. And this because in order to move all those operations from, say, a smaller instance to a larger instance, even if the switchover time is a few minutes, the quality of service degrades during that interval. So, we talked about, reputation, Dwitrisha. If you see a website down, even because they're doing something positive, it could add as a knock to us. You know what I mean?
Mm-hmm. So it's very important to try to avoid that time.
Absolutely.
So yeah, so next, scalability is sometimes more nuanced than simply provisioning more resources, that is scaling out, or larger resources, that is scaling up. On the server tier, increased demand can increase competition for specific types of resources such as CPU, memory, and network bandwidth. Cloud service providers typically offer virtual machines that are optimized for compute heavy workloads, memory intensive workloads, and network intensive workloads. Knowing your workload and picking the right type of virtual machine is essential as throwing more or larger virtual machines at the problem. It is better to have 5 virtual machines handling compute heavy workloads than 10, even if virtual machines optimized for CPU intensive workloads cost 20% more than the generic virtual machines.
Sure. So if we're doing some sort of like data analysis using data science software and we're accessing databases or we're working on from the application tier, we're going to need to have the right size. We're going to need to know what we're doing. If we're network bound, we need to have the right network resources in our VM to make sure that we're getting the most throughput. So these are really, really good points. And so this is where you may store information on the data tier, like your customers, your order numbers, the addresses, and other important data. Databases can be the heart and soul of an application that we provide to our users. And without the ability to scale beyond the static hardware resources that we have, you could risk your application being unavailable. Now, we don't want that. And in the data-oriented applications where there are a high number of reads and writes or both to a database or a storage system, the round trip time for each request is often limited by the hard drive time reads and writes.
Mm-hmm. So I think right now there's a time for story time, and I think our audience is excited to hear a story as well. So Jay, is there a story you would like to tell us about when you actually had to use scaling for data tier?
Sure. So years ago, I worked at a big company called, or a media company called BuzzFeed, and nobody could tell what color a dress was. It was either blue and gold or gold and black. I don't even remember. But what we were doing is that we were collecting votes in an application for a poll. And we were using a MongoDB database, which is great to scale out. And what we would need is, say, very, very busy applications need to be able to scale up, scale down. And so what we would be able to do is use our cluster to be able to add additional database nodes that we need to do the processing of all the votes so that all the votes were collected. Sound good?
Yeah, I definitely remember the time when there was a debate going on between a white and a blue dress, and I probably voted as well. But getting to know what actually went on behind hosting that is pretty cool, and I think our audience enjoyed that as well. So thank you, Jay, for sharing the story with us.
No problem. Say, hey, it's time for just a mini demo. It's just to show you some things that I think are interesting. About specifically Azure, we've got like this whole suite of services that can help you build reliable elastic solutions. So whether it's using say a web app or say Cosmos DB, maybe a virtual machine scale set, we'll talk about that in just a minute. You're able to use all of these solutions to come together and build what you expect, an elastic, reliable solution that can grow and shrink with you. Well, Dwitrisha, you know what time it is now? We did story time, but now
Knowledge check time.
It's time for more Q&A. And so our Q&A, we can answer those questions on Learn TV. Remember, you can go to aka.ms right here, Learn Live TV. So, Dwitrisha, I'm going to ask you this next question. And if you're watching now, make sure you take the poll. Which of the following choices is not one of the benefits of scaling when scaling is done well?
Okay, so what does our audience have to say about this?
Let's take a look.
Yeah.
I think that they're gonna get this one. I think we talked a little bit about what exactly this is, but Dwitrisha, why don't you just tell me?
Yeah. So like from what we learned, I think scaling doesn't actually benefit the complexity of deployment. So I'd say less complexity in deployment.
That makes sense to me. And so hopefully you got to answer our poll. You agreed less complexity in deployment. And so one of those ideas of, say, good complexity is, say, I don't know, having a number of nodes that's able to fail and the rest of your application is able to stay online. By having some good complexity, you're able to kind of hide some big problems. So we got another question, Dwitrisha. What do you think? Let's go to it.
So which of the following choices is a benefit of horizontal scaling compared to vertical scaling? Higher availability, higher granularity in scaling, zero downtime as scaling occurs, or all of the above?
Very cool. Well, everybody, let's take a second, give you just a few seconds to go ahead and answer this poll. I am really, really glad that you're all taking part. I can see your answers right now. We got a bunch of votes. Thank you very much. Let's see what our answer is, though, Dwitrisha. What do you think?
So I think it is all of the three reasons to prefer horizontal scaling over vertical, since it has higher availability, that is, it has less downtime, and also higher granularity in scaling, since we are actually creating more resources than increasing the existing ones.
Yep, that's right. Because all those three reasons that horizontal scaling, it's just more popular than
Mhm.
vertical scaling because we don't want things to go down. Um, I want my website up.
So just like VM in any computer you may use, most hardware upgrades are going to require us to stop and then shut down. Is that correct, Jay?
Yeah. Um, when you work with a virtual machine, you've got to remember that it's almost like any other computer that you might use in the context that, say, a hardware upgrade. Like if you're going to put a new CPU in your physical computer, you need to not access that CPU in the process. You're going to need to turn off the computer, pop out that old CPU, and put in a new one. And so that's going to limit, how quickly and how seamlessly a migration or an upgrade would be. So
And so that would be an example for vertical scaling. That is an issue with it, right?
absolutely. If we're looking to make our server bigger, we're gonna have to turn it off, and like I
Mhm.
said, that's gonna take away. So everybody, remember, ask questions in the chat. I can see your questions. We will answer them directly. Just go ahead and pop them in. I know our moderators are ready for you. So we're going to talk about scaling on the cloud and scaling up or out to handle increased demand, and in or down to reduce costs when demand lessons can be performed manually by cloud administrators. So, for example, a watchful administrator can detect that demand is increasing and use tools provided by cloud service providers to bring additional virtual machines online, scaling out, or replace existing virtual machines with larger ones with more CPU and more memory, scaling up. The key word is watchful. If demand peaks and no one is aware, the system as a whole may become slow, even unresponsive to end users. And conversely, if you scale up or out to handle heavier loads and fail to scale back when the load decreases, you end up paying for resources that you don't need. And that's why popular cloud platforms offer auto scaling, mechanisms that scale to resources in response to fluctuating demand without human intervention. So we don't need a watchful administrator. And we can use these two primary approaches to auto scaling.
Yes, so time-based auto-scaling is appropriate when the load fluctuates in a predictable manner. For example, many organizations' IT systems experience the highest load during working hours and may experience little to no load in the wee hours in the morning. Domino's Pizza's website may experience load at all hours of the day since it operates more than 16,000 stores in nearly 100 countries. But it predictably experiences higher than normal load during the certain times of the day, like holidays and, like Jay explained, when a team wins a game and something like that.
Yeah, I know when there's say, a big sports game on television and I want to hang out with my friends, I'm going to order a pizza. And a company like Domino's, they need to be prepared for more than just me. They need to be prepared for lots and lots of people like me who are interested in checking out the big game or something like that while chomping down on a slice. This session's starting to make me hungry, Patricia.
Me too. Everybody wants a good pizza.
Absolutely. Hey, I'm in Brooklyn, I know. Um, so scaling based on metrics such as CPU utilization and average request wait time is appropriate when loads are less predictable. Monitoring is a crucial element for effectively auto-scaling resources based on performance metrics because it enables the autoscaler to know when to scale. So monitoring enables the analysis of traffic patterns or resource utilization in order to make an educated assessment about when and how much to scale resources in order to maximize quality of service while minimizing costs. So we're delivering as much value as we can while keeping eyes on how much things cost us. So I think that makes a ton of sense to me. How about you, Dwitrisha?
Yeah, I think it is super important when hosting something because we want to make sure that it is costing less, but at the same time, we want the best service to deliver.
Sure. So we've got a question from one of our viewers. And so they want to know, Dwitrisha, what are the best practices for developing scaling policies? You know what? I would believe that a best practice for developing a scaling policy is really dependent on what your application looks like. So if you're running a very heavy application that needs a ton of front-end resources, you may want to build something that looks at beyond just CPU load. Maybe you want to look at the frequency or how long it takes someone to actually complete a request. So I feel like if you do some analysis based on the amount of time that a request is taking, you can then make some decisions on whether or not you're scaled properly, because there could be some bottlenecks between, say, your application and your database or one of the other places. Maybe you don't have the correct network configuration. Like we said, we may be network bound. So we need to do some analysis, and that's why metrics really, really help us. So we're moving along. It's demo time, Dwitrisha, and I love demo time. And you've got a quick demo for us, don't you?
Yes, and I want to make sure everybody looks at the demo and realizes that how easy it is to actually create a scale set, because this was my first time creating a scale set and it was a very smooth experience and I want to share it with everyone.
Sure. And Dwitrisha, a scale set, of course, is a collection of virtual machines that are managed together in Azure that allows people to scale up automatically, scale out automatically, and add additional nodes without actually having to physically do it themselves. They don't have to sit there, point, click, and create. They can go ahead and set up metrics that'll create those VMs for them, or other triggering methods. We'll talk about them in a second. So we got a question, and someone wants to know is how big can a scale set be? You set those limitations. Scale sets are based on what your limitations of your account are and the number of servers that you want to actually have available to you. So we'll show you in a second just how you can set the number of instances for your auto scale and make a determination if you have enough or too many. You can look at the metrics. So you ready to show me that demo, Dwitrisha?
Absolutely, Jay. So here I'm just going to go and search for scale sets, and I'll open the virtual machine scale set. So here I'm clicking on create virtual machine scale set, and since this is the first one, this is so here I'll select my resource group and I'm just gonna set it to demo for now. I'll give a name to this virtual machine scale set and I'll set it to demo scale set for this demo. I'll be giving the region as East US, and I'll select availability zone number 3. You can select as many as you want and whichever one you want. So I'll just make sure we have Ubuntu image running, and then I'll be using the username option, but you can always use the SSH public key as well. So I'll just enter my password here, and then I'll move on to disks. Here you can add an additional ones if you want, but I'm just going to keep the default and move to networking. I'll then open the network interface and I'll make some changes, like I'll set HTTP, HTTPS, and SSH to open, and then I'll go ahead and enable the public IP address. After that, I'll add a load balancer, and then I'll move on to scaling. So here I'm just going to select a application where the minimum is 3 and the maximum is 10 scale, 10 virtual machines, and then I'll move ahead to management. Here I won't be making any changes for now. I'll just keep the default and I'll move ahead to health. Here, I'll enable the application health monitoring, and as we can see, the port 80 is running and it is going to the / path. Now I'm going to go ahead and take the most important part that will actually help our application to run. And this code has all the application requirements and starts them. And I'm going to copy it and go ahead and place it in the custom data. So next I'm going to move ahead to tags, and I'm not going to be adding any tags for now. So I'm just going to go to the final state, that is review and create. I'm going to check all the information just to make sure that I've selected everything correctly, and then create. And as you can see, the deployment has started, and it hardly took us 2 minutes to actually deploy our first ever scale set.
Sure, and you can do that, say, via Azure CLI. You can use the API and use whatever code or language that you're already using, or you can use, say, VS Code. There's plugins there. You can do all these things to be able to create these services. Dwitrisha, it's poll time. You ready?
I'm very excited to see what our audience have to say.
Yeah, and you know what? Our audience, they keep asking great questions. Matter of fact, one of our guests wants to know, what's the best testing tool for testing if my services can scale effectively? You know, there are a lot of load generators is the best kind of way to put it. There's different software that can test by adding additional load to your apps. I also like the idea of chaos engineering. There are applications like Chaos Monkey, Gremlin. You can Google those, and you'll be able to go ahead and create things that are broken, and then you can test. Am I scaling properly? You can add additional load to a server. You can add additional network traffic. You can do all these things to make sure that your application responds correctly and stays online. So let's get to this question, all right, Dwitrisha?
Absolutely.
So I'm going to ask you, Dwitrisha, you are a cloud administrator in charge of ensuring that your application, or say your organization's public-facing website remains fast and responsive at all times. The site is hosted in Azure App Service. It sees the heaviest traffic between 8 a.m. and 5 p.m. each day, but the load is somewhat inconsistent from one day to the next. In addition to experiencing frequent burst loads of up to 10 times the normal traffic. These bursts are difficult to predict, but slow the site to a crawl if additional resources aren't brought online rather quickly. What approach would best provide the best balance between responsiveness and cost? So what do you think, Dwitrisha? What do you think our audience is going to say?
I think they can answer this correctly. So please answer in the poll, everyone. We are very excited to know what you want to answer.
Sure. So, Dwitrisha, what do you think it is? Well, let's say, what do you think are the wrong answers first?
Okay, so I would say option A is not the correct answer, because scheduled auto scaling enables the site to scale to meet demand during working hours, but it doesn't actually address unpredictable spikes in traffic. Option C is not correct, since the load during working hours varies each day. So we are better off using metrics to determine how to scale for cyclical loads the site experiences. And option D is not ideal, because manual scaling increases administrative costs and is less reliable than auto scaling. So
Sure, so
I'm going to go ahead with option B.
Correct. Properly configured metrics-based auto-scaling makes sure that the site is scaled for the right amount of cyclical loads as well as burstable loads.
Okay. So Jay, this is time for the next story time. And have you ever implemented auto scaling in production before? Because we learned all of this. It was very exciting to learn, but we want to know if actually ever you have implemented it and it would be such a great thing to learn.
Absolutely. I used to run a website with some friends that followed the New York Yankees. Yeah, got my little Yankees tattoo right here. And when things happen, big news, players get hurt, you name it, they win a big game, we'd see a huge burst in users that wanted to access the website. And so this would send additional load to the web server tier, and that would handle requests from the load balancer that users would access first. And so I used auto scaling to make sure that at the servers that were online, if they had a load, say, of over 75% CPU, the auto scaling would start up 2 more virtual machines. And then it would continue to do that until it would wait for the CPU process to go down. And once the CPU went back to a normalized space and we weren't seeing that high traffic across all, then it would start removing the additional virtual machines. And so, like it said, the big balloon was filled with air. Well, the balloon would go back to normal in its normal size when the big traffic would end, and we would save money. Cool. So let's keep going, and we talked a little bit about load balancing, and we're going to talk a little bit more about load balancing. So I've got a question here, Dwitrisha, and it comes from one of our guests, and I love this question. What do I do to make sure my servers are all serving the same software? So Dwitrisha, have you ever heard the term configuration management?
Yes, so it basically setting up the server we would be using and then managing it.
Sure. Well, configuration management at scale can actually allow us to, say, codify what exactly we want installed on these machines. And so we can use a lot of different services that will, kind of like what you did before when you pasted in the application installation information. We can use things like, say, we can use that box to go ahead and put in our additional data and use what's known as Cloud Init. Cloud Init's service, it's native, it allows us to start up something like batch. So there you go. Let's get into load balancing though. What do you say, Dwitrisha?
Absolutely. So scaling out by bringing new virtual machines online when traffic increases is an effective strategy for scaling to meet demand. The fact that virtual machines can be provisioned quickly is essential to achieving elasticity. But bringing additional servers online isn't helpful unless the traffic is distributed between those servers. Overall, this helps the system handle the increased load. And that is why load balancing is critical to elasticity, as it can dynamically adjust the number of resources devoted to a task. The need for load balancing it stems from 2 basic requirements. First, throughput is improved by parallel processing. So if a single server can handle 5,000 requests per unit of time, then 10 perfectly load balanced servers can handle 50,000 requests per unit of time. And second, load balanced resources yield higher availability. And what that means is that instead of forwarding a request to a server that is already struggling to keep up, a load balancer can direct the request to a server with a lighter load. Also, if a server goes offline, the load balancer recognizes it and it can direct requests to other servers.
Very, very important. And so load balancing really helps us hide a lot of the failure that may happen behind the scenes. Now, the load balancer itself becomes a single point of failure, though. If it fails for any reason, even if all those back-end servers are still functioning, no client requests will be processed. So you'll have to ensure whatever you build behind the scenes has enough redundancy to best benefit from load balancing. And you may want multiple load balancers, and that's possible. So we'll talk about some normal load balancing methodologies that help reduce that failure or mask that failure. SSL offload. So instead of serving all the requests via SSL, secure socket layer, the client connection to the load balancer that's made via SSL, that'll be served from the load balancer as opposed from the certificate being and the secure connection being served directly from the virtual machine. That'll take a lot of stress off the servers. TCP buffering is a strategy to offload clients with slow connections to the load balancer, and then caching in certain scenarios. The load balancer can maintain a cache for the most popular requests or requests that can be handled without going to the servers, like static content, like images, videos, things like that. And that'll help reduce the load right there on our servers. And so there are several load balancing strategies used in the cloud. And one of the most common is equitable dispatching, which uses a simple round-robin algorithm to distribute traffic evenly between all nodes. It does not take into consideration, though, the utilization of individual resources in the system, nor does it factor in the request execution time. This approach tries to keep every node in the system busy and is one of the simplest to implement. Sounds good to me, Dwitrisha. We want simple, don't we?
Absolutely. That is, we want it simple but working great. Mm-hmm. So hash-based approach tries to ensure requests from the same client for a duration of a session are directed to the same server every time, by hashing metadata, defining each request, and using the hash to pick a server. If hashing is done properly, requests are distributed relatively evenly among servers. One benefit of this approach is that it lends itself to session-aware applications, which can store session data in memory rather than write it out to a shared data store, such as a database or Redis cache. A drawback is that every request must be hashed, and this introduces a small amount of latency.
Absolutely. Very, very cool. And so there's some other load balancing strategies. And if a particular server is bogged down by, say, processing a request, load balancers that utilize round robin or hash dispatching algorithms will forward the requests to it anyway. There are other more sophisticated strategies for balancing loads across multiple resources that take capacity into account. Two of the most commonly used metrics for gauging capacity are request execution time. And strategies based on this metric are use a priority scheduling algorithm, whereas the execution times are used to pick the destination for individual requests. Resource utilization. That uses strategies based on metric use, like CPU utilization, to balance across nodes. The load balancer maintains an ordered list of resources based on their utilization and directs each request it receives to the resource experiencing the least load. So it sounds like with that particular methodology, Dwitrisha, what we're doing is making sure we're getting the most out of the resources that we've created, right?
Yeah, sounds great.
Absolutely. So we've got a question, and the question is from Rob G. In the case of SQL Server, say VM managed instance or SQL database, do we have a way to do horizontal scaling? I believe we can add read nodes. I'm not the biggest SQL person, but I'm fairly certain we could probably add additional read nodes for our horizontal scaling. I will double check, and if you want to find me online on Twitter at Jaydestro, Jaydestro, you can ask me there and I'll double check with you. Thanks for the question, Rob. We really appreciate it. But we're going to move on and we talked a little bit about load balancers, Dwitrisha.
Mhm.
It sounds like you're going to show me a little bit more about how, say, metrics are set up and scaling policies are done, and all the configuration. So you ready to go through that for me?
Sure, we'll be taking a deeper look at the load balancer we created earlier. So here I'm going to go up and open the resource group that we had created earlier. And I'm gonna go ahead and look for the load balancer. So I'll just open the load balancer here. And okay, so the demo scale set load balancer is for the demo scale set scale that we created, and it will be according to what you create, it will change. So here, as we can see, it has a number of tabs, and you can go ahead and check all kinds of configurations. But first here, I'll just go ahead and check our front end configuration. That is, I'll click on view front end IP configuration, and here I'll just go ahead and select load balancer front end. And here we can see all the rules. And here we have this LB rule, and it has a TCP protocol because it is it has created a TCP based protocol rule. So next I am going to go back, and here we have the NAT pools, and the NAT pool rules are actually used for networking the backend IPs to our front-end IP address. And so these has all these configurations that I'm not going to be changing right now, but you can also make your own load balancer and check them and see if they differ. So next I'm going to go ahead and check out our backend pools. And this is actually the place where our virtual machines are held. So here we can see the scale set we created, and the IP address is also mentioned here. So what we are going to do is we'll just go ahead and take a look at the health probes that we created, and the health probes make sure that our application is online and our backend is actually responding. So we have a backend probe here named TCP probe because it has a TCP based protocol rule, and here we specify the port that we are going to check our backend host and to make sure the application is online. And as we can see, the port here is 80, and for more information we can always click on the I button, and it will display the information for any beginner who wants to actually find out what it means. And we have an interval of 5 seconds, and that means that it will be checked every 5 seconds for any kind of failures. And what unhealthy threshold means is that if there are 2 consecutive failures, then it will stop.
Very, very cool. That's a great look at these load balancers, Dwitrisha, that Azure provides. And I've used load balancers so many times. BuzzFeed, we use tons of them. I've set up physical load balancers where you actually have to have servers in both spot or using Linux or actual load balancer appliances. And then once I went into the cloud, I started using load balancers that are virtualized, like the one you just showed me.
I think it's a great thing that we are having these story times to actually learn about the practical usage of this load balancer after the demos. So thank you once again, Jay, for sharing these stories.
No problem. And so, hey, everybody, we're rolling towards the end part of this session, and we're getting closer and closer. And I just want to remind you, you can go to that chat, you can ask questions, you can answer the polls that we've done. It's great having you part of this session. We can't do these unless you're part of them. All right, Dwitrisha, you ready to kind of move along into our last section?
I'm very excited to learn about it.
So we're going to talk about serverless. And serverless computing enables developers to build applications faster. They're not building all the back-end infrastructure. They're not managing it. With serverless applications, the cloud service provider automatically provisions, scales, and manages the infrastructure required to run the code. And Azure provides you with options to deploy code and spend less time focused on the hosting environment, such as your virtual machine or your containers, Kubernetes, you name it. Serverless computing just enables you to work more by giving you the ability to focus on your code.
That sounds like a win-win situation. So serverless computing offers three primary benefits to the organization that leverages cloud computing. So what are those? Lower computing costs. So you are paying for what you use. And instead of paying for the servers with unused capacity sitting idle, you're paying for exactly what you consume with Azure Functions and Azure Serverless Platform as a service. So automatic scalability. Cloud providers offer mechanisms for scaling IaaS services in products such as virtual machine scale sets in Azure, and they also provide manual and automatic options for PaaS services. But even if scaling is performed automatically, a cloud administrator has to enable auto scaling and configure it so that the cloud provider knows how and when the scaling should occur. Reduce administrative costs. Serverless lets you focus on executing code and workflows while transferring responsibility for everything else, including maintaining the underlying platform to the cloud service provider.
And so the most common example of serverless computing in serverless functions, or I should say is serverless functions. You upload code to the cloud, you tell it when to execute, and the code can be written in a variety of languages, Java, C#. There's tons of them. And actions are triggered by input, like this particular chart that I have here. Uploading, say, an image to an Azure Blob Store, that getting processed into a function, serving that into our custom vision service, storing the information about it in an SQL database, and then giving you the ability to look at the data in Power BI. Ooh.
So databases as a service is just as important to our elasticity. This PaaS service extends to our data layer as well. Rather than just installing a database management system on a server, we are able to leverage hosted database services such as Cosmos DB or Azure SQL. We get all the benefits of using these common databases without having to manage all of the backups, upgrades, and other critical database administrative tasks.
And people are asking, what would you advise if someone wanted to learn more about serverless? Same answer as before that we were giving about this session. Go to Microsoft Learn. You can go to Microsoft Learn and you can get all sorts of interesting education on these subjects. And I think serverless is one of the best ones to kind of look at. There's a ton of modules you can start looking at. And so, Dwitrisha, we're down to our last knowledge check. Let's see what we've learned, okay?
Mm-hmm.
Okay, Dwitrisha, which, and everybody, if you're watching now, please make sure you're answering in our poll. Which of the following is not a scenario for which you would consider a serverless computing solution? Code that runs at a specified time each night to back up mission critical data, a data that experiences varying loads at different times of day with an occasional 10x spike in traffic, a website that experiences varying loads at different times of day with occasional 10x spikes in traffic, a well-defined business workflow that kicks in every time an invoice is uploaded to cloud storage, or say E, code that serves as glue between other cloud services. So, Dwitrisha, while our viewers are voting, I'm curious, what do you think is the correct answer?
So I think here only option C is the one that must run constantly, because the website must be running even when there are no requests, because we have the front end that whenever a user visits, he'd obviously want to see it to know that the website is running. So on the other hand, running at a specified time each night A database experiences varying loads at different times of the day, well-defined business workflows, and a code that serves as a glue between other cloud services. These all are ideal examples of serverless functions. So option C it is.
Yeah, you really can't use functions for, say, a web front end purpose. Like your blog post can't be really uh, served in a function. You may want to have functions that are supportive on your web page that maybe your blog is on, and maybe there's services that you want to run, or you want to collect data. But the front end will require an active server rather than, say, a triggered based event.
So, Jake, can we say that serverless solutions are generally used for tasks that run frequently but not constantly?
I think so. Absolutely. We can use them kind of like a cron, as we call them, an automated job. We can do it that way, or we can trigger it from another service. These are all really useful.
Mhm.
So, uh, someone wants to know what's the difference between, say, a function and a service fabric. Service fabric tends to be a collection of lots and lots of servers that is for, say, microservicing and distributing your application. Functions are more for, like I said, they're kind of triggered events. A microservice is more like a piece of a service that's running together. And then a service fabric is the entire distribution of it. All right, so Dwitrisha, let's finish up and summarize the things we've discussed today, okay?
Yes.
So here are some of the key points presented in this module today about elasticity. VMs and other cloud resources, they rarely experience constant loads. Sizing compute capacity to fit peak loads ensures a quality of service. Elasticity refers to the ability to add resources to handle higher loads and remove resources when the load decreases. And elasticity is achieved in the cloud by scaling resources such as virtual machines and databases.
Mhm. So next we are going to talk about scaling, scaling in and scaling out. That refers to that is actually horizontal scaling. Refers to increasing and decreasing the number of resources devoted to an IT solution. Scaling up and down, vertical scaling, refers to replacing existing resources with more or less powerful ones. So I think we all learned more about scaling from Jay's story time, where he had used it at BuzzFeed for voting. So effective load balancing, that can be metrics based or time based, is crucial to implementing scalable cloud services. And load balancer use different kinds of algorithms to distribute load, including round robin and hash bit algorithms. And I think we have been able to conclude how crucial load balancers are when creating a project.
I think we have, and I love what you showed me about all those configs. And so load balancers can increase availability by monitoring the health of those backend resources. And so because a single load balancer can represent a single point of failure, or as we call them SPOFs, load balancers are often deployed in pairs. One fails, the other one can come up, and we can use DNS or services like Front Door to manage them. And then serverless helps us focus on our code, and then helps us work less on that infrastructure. So we're actually building our apps and not necessarily building all the underlying stuff that makes it come together. And so once again, I want to remind you all that this session that we just watched, it's all based on Microsoft Learn. It's free training. Dwitrisha, I'm so glad you helped me get through this module with everybody. And I hope they all go to AKAMS/CMU Scale Cloud so that they can take it. I know you got your points for it, right?
Yeah, and I hope everybody can go and as you can see, it has 1200 points. So it will really help you, and then you can also compete with your friends and check who reaches a higher level. So
Sure. Like
hope everyone enjoyed this. Yeah.
Cloud Fortnite.
Yeah. Exactly.
And if you really enjoyed this session, then check out Nitya's sketch notes on cloud-skills.dev. Nitya's incredible. She's going to be doing a lot more of these, if I'm right. You can check her website. You can see these different sessions. I love this. She loves to capture what happened. And I think, Dwitrisha, you're going to love this. It's going to be something wonderful to you to take back to your class and to say, this is a talk I did.
Yeah, it looks beautiful, and how it summarizes everything that we talked about, and we can just learn about it and revise it at a glance. So next, these are the upcoming sessions, and the older sessions are also available on Learn. So the previous session and this session recording will be available on aka.ms/learn live. And make sure you register and come back for the next 3 sessions that we'll be having, where we learn even more about cloud admin, including automating and monitoring cloud resources and implementing cloud security.
Cloud security, so important, just absolutely important. And so it's great to know that we're going to kind of hit that. And so if you enjoyed this session, here's some things that you can do after. One, you can go to that Learn module, like I said, AKMS/CMU Scale Cloud. You can take this module and learn a lot more if you want. We kind of just got right through it. If you want to watch a recording of this session or the previous sessions, aka.ms/learn live, just like Dwitrisha said. And then, of course, this is the part I really need from you all. I absolutely beg of you, please take the session survey. Go to aka.ms/reactor/survey. The event code is right there, 12922. And let us know what you thought. These are only going to get better with your help. So if you tell us what you need, we'll try our best to make sure we get it in these sessions. So, Dwitrisha, that's it. We got through everything. We answered everything. At least I tried. And we I think we did a great job. And I'm proud of you. I think you did a great job. And so I want to say I'm so glad I got to do this session with you. It's been really nice getting to know you. You know, you are all the way across the other side of the planet, and through weird hours and whatever, we still got a chance to make sure that we did this for everybody.
Yeah, and I got to learn so much from this module and hosting this with you. So thank you, Jay, and I hope our audience learned as much as I did and also enjoyed learning. And so I hope everybody checks out the module on Microsoft Learn and goes through it.
Absolutely. So if you want to find out more from me, I am on Twitter at JAYDESTRO, Jdestro. You can check out my weekly show here on Learn TV. It's called Azure Fun Bites. It's every Thursday, 2 p.m. East. Dwitrisha, you got any more interesting things coming up? Or was this your big thing for the year so far?
This was my big thing for the year so far, like the first one. But I'm hoping to do more such events, maybe in the student summit that is coming up for ambassadors.
Yep. Well, make sure you check out Microsoft Ignite. That's coming up not too far from now. It's got open registration. You can go ahead and register, and you can take part in some of those student sessions. You can watch. I think you're going to love what you're going to see this year. So, yeah. Dwitrisha, I think you and I are ready to give everybody the big wave goodbye, okay? Yes. So, you ready? Let's give them the big wave goodbye. Goodbye, everybody.
Bye, everyone.
Thank you so much for watching, and make sure you watch the next sessions that are coming up. Thank you so much. We appreciate it. We'll see you all soon.
Bye, everyone.